What's happening, dogs? Mr. Allen here. We're going to be graphing some polynomial functions using x and y intercepts in this video. So for the first one, I've got k of x equals 2x cubed plus 8x squared minus 24x. Well, how am I going to get my x-intercepts? I'm going to need to factor and set those factors equal to 0 using the zero product property. So let's go ahead and do that. What do I notice about all of these here? I can take out a 2. They're all divisible by 2. And I can take out an x. Always be on the lookout for a GCF when you're factoring. You can do that first in so many different factoring problems to simplify your life. So always look out for GCF, okay? So I'm left with x squared plus 4x and then minus 12. There we go. And now I need to continue factoring here, which is great because that's my favorite F word. What multiplies to negative 12 adds to 4? It's positive 6. And negative 2. All right. If you cannot factor, do not even attempt graphing polynomial functions yet, okay? Got to be able to factor. All sorts of different types of factoring here. This one was GCF along with reverse FOIL, AM method, whatever you want to call it, right? What multiplies to this, adds to that, whatever. Now I can get all my x-intercepts because I can set my factors equal to 0. All right, so that was k of x, and then we set it equal to 0. So I'll have 2x equals 0. I will have x plus 6 equals 0, and x minus 2 equals 0. Well, dividing by 2 just gets me 0. Minus 6 just gets me negative 6. And adding 2 gives me positive 2. So let's plot them. We've got positive 2. Negative 6, 1, 2, 3, 4, 5, 6, and 0. So there we go. Positive cubic looks like this, right? Sometimes it's helpful to just do like a little rough sketch off to the side. I've got 3x intercepts, no big deal. It's going to pass through like that. So I'm going to go up a little higher here, back down to it, curve up through it, whoop, boom. Label it k of x. Money, baby. Money. Did people say that? I don't know. Let's also write out our x-intercepts here because they might ask for that, right? They might have like a little spot for x-intercepts. Boom. 0, 0, negative 6, 0, and 2, 0. And then they might have a spot for like y-intercepts. That's going to be 0, 0, right? Just passes through at the origin. The x-intercept and y-intercept are shared. Okay, they are one and the same. They're buddies, okay? All right, next one. We have a cubic polynomial once again, but this time I have 4 terms. How do I factor something like that? Well, if you're thinking factor by grouping, you are thinking correctly here, people. All right, group the first 2, group the last 2. And what this allows me to do is use GCF. So I'm just looking at the GCF of these first 2 here, which is x squared. So I'm going to take out an x squared, and what am I left with? Well, here I'd be left with an x, and here I'd be left with a plus 6. Now I look at the second 2, right? I'm just grouping it so I can just focus on 2 things, okay? Well, I can take out a negative 9 here. Fun fact, anytime that's negative, I take out the negative with it. And then negative 54 divided by negative 9 is going to be positive 6. These 2 should always match up. Otherwise, you did something wrong, or it's just not factorable by grouping. Okay, so x plus 6 is one of my factors. This is actually like a GCF of this large term here and here. So these 2 things are in common between these 2 large terms. Take it out, it's a GCF. I got x plus 6, and then we have x squared minus 9, which can be factored using a difference of 2 squares. So we'll do that, and then we are in wonderful factored form. I know we're eating into the graph a little bit here. Lo siento. Boom. So this is p of x straight through. But then we'll go to solving, so I'll set that equal to 0. Okay, it's still p of x, but my strategy is I'm going to set it equal to 0. So when we get that equal to 0, I'm going to change colors here before it gets all lost in the sauce here. This one's going to give me x plus 6 equals 0 is going to give me negative 6, but I'll write my work out. X plus 6 equals 0, x equals negative 6. That's one of them. Then I have x plus 3 equals 0, so I subtract 3, I get x equals negative 3. And then x minus 3 equals 0. So I'm going to get x equals positive 3. Okay. Now we can graph this thing. We have negative 6, 1, 2, 3, 4, 5, 6. Negative 3, positive 3. And what's my y-intercept? Negative 54. 0, comma, negative 54. If you want full points, Make sure you label that bad boy right there. If it's an unscaled y-axis, definitely want to scale it. Now, when we're coming through this thing here, I got to plan out my, my attack here. I've been embarrassed before in class where I'm like, yeah, it's not right. It's going to be pretty close to like right in the middle there because these two are evenly spaced about my y-axis. So I'll probably just, pretty much make that my minimum-ish, sort of, kind of, beautiful. P of x, finito. Okay. If they ask for x and y intercepts, like we talked about over there, my x-intercepts would be negative 6, 0, negative 3, 0, and 3, 0. My y-intercept, like I have there, but there may be an answer blank for it for you to fill that stuff in, 0, comma, negative 54. Boom. It's nice, man. Some nice graphs, a lot of colors. The math's popping. I always like the math to pop. It's one of my favorite things. All right, so there we go, guys. Graphing polynomials, polynomial functions. Did a little factor by grouping, a little GCF and AM method. It's all fair game in the land of polynomials, so make sure you're up on your factoring. If you're not, I got a ton of videos on factoring. Check them out. And if you guys have any questions, pop some questions in there. Find me in the halls, and have a great, great day. Thanks for watching.